Hello everyone, welcome back to Maths with Mamta. Today we are starting one of the most important and interesting chapters of trigonometry. In this video, I'll explain all the basic concepts, ratios and ideas you need to understand before solving questions. So let's begin. Trigonometry is the study of relationships between the sides and angles of a triangle. The trigonometric ratios. In simple terms, trigonometric ratios are the ratios involving the sides of the right angle triangle such that it expresses the relationship between the angles and the length of the sides. To understand these ratios, let us consider triangle ABC right angled at B. The side opposite to the right angle is called the hypotenuse. The side opposite to this angle A is called perpendicular and side adjacent to angle A is called as the base. So sine of angle A is equal to sine A, which is BC by AC, that is perpendicular by hypotenuse. Cosine of angle A is equal to cos A, which is AB by AC, which is base by hypotenuse. Tangent of angle A is equal to tan A, which is BC by AB, that is perpendicular by base. Cosecant of angle A is cosec A, which is equal to 1 by sin A, which is AC by BC, hypotenuse by perpendicular. Secant of angle A is equal to secant A, which is 1 by cos A or AC by AB, that is hypotenuse by base. Cotangent of angle A is equal to cot A, which is equal to cos A by sin A or AB by BC, that is base by perpendicular. The trigonometric ratios are very closely connected by a relation. Now let us see how. There are two types of relations, reciprocal relations and quotient relations. Now since sin A is equal to perpendicular by hypotenuse and cosecant A is hypotenuse by perpendicular, so which implies sin A and cosecant A are reciprocals of each other. That is sin A is equal to 1 by cosecant A and cosecant A is equal to 1 by sin A. Similarly, cosecant A and secant A are reciprocals of each other. That is cosecant A is equal to 1 by secant A and secant A is equal to 1 by cosecant A. Again, tan A and cot A are reciprocals of each other. That is tan A is equal to 1 by cot A and cot A is equal to 1 by tan A. The quotient relations. Since sin A is equal to perpendicular by hypotenuse and cos A is equal to base by hypotenuse. So what is sin A by cos A? Sin A by cos A becomes perpendicular by hypotenuse into hypotenuse by base. So we get perpendicular by base. What is perpendicular by base? It is nothing but tan A. So tan A is equal to sin A by cos A. Similarly, cot A is equal to cos A by sin A. Now if one of the trigonometric ratios is known, then the remaining trigonometric ratios of the angles can be easily determined. There are 6 trigonometric ratios, that is sine, cosine, cosecant, secant, tangent and cotangent. This happens because if we pair 3 sides of a triangle, then only 6 pairs can be made. Now this is the table for the trigonometric ratios for 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now from this table, we can observe that as angle A increases from 0 to 90 degrees, the value of sin A, tan A and secant A, they all increase, whereas the value of cos A, cosecant A and cot A decreases. The value of sin A or cos A, they never exceed 1, whereas the value of secant A or cosecant A is always greater than or equal to 1 or less than or equal to minus 1, where A is an acute angle. Similarly, the values of tan A and cot A, they can have any real values. Trigonometric ratios of some angles. Now let us take the trigonometric ratio of 45 degrees. Let triangle ABC be a right angle triangle where B is equal to 90 degrees and angle A is equal to 45 degrees. So clearly angle C is equal to 45 degrees because the sum of the angles of the triangle must be 180. So when angle A and angle C are 45, AB and BC are also equal because side opposite to the equal angles are equal. Let AB is equal to BC be equal to A units. Then AC is equal to square root of AB square plus BC square, which is A square plus A square, that becomes 2A square. So it becomes root 2A. Therefore sine of 45 degrees is equal to BC by AC, that is perpendicular by hypotenuse. So this becomes A by root 2A, which is equal to 1 by root 2. Similarly, we get cos 45 degrees base by hypotenuse. So A by root 2A, which is 1 by root 2. Tan 45 degrees is perpendicular by base, which is A by A, which is equal to 1. Similarly, cosecant 45 is reciprocal of sine 45, which becomes root 2. Secant 45 is 1 by cos 45, which is root 2. Cot 45 is equal to 1 by tan 45, which is equal to 1. Let's find out the trigonometric ratios for 60 degrees and 30 degrees. Now let us consider this equilateral triangle ABC with each side equal to 2A units, and let each angle also be 60 degrees because it's an equilateral triangle. From A, we draw AD perpendicular to BC. Now BD is equal to DC because in the equilateral triangle, the altitude and median are the same. Also, this angle ADB is 90 degrees, and since this AD is bisecting BAC, so this angle BAD becomes 30 degrees. From right angle triangle ADB, we have AD is equal to square root of AB square minus BD square, which is nothing but root of 2A the whole square minus A square, or root of 4A square minus A square, which is root of 3A square, which is equal to root of 3A. Trigonometric ratios of 60 degrees. In the right angle triangle ABD, the base is BD, which is A, perpendicular is root 3A, which is AD, and the hypotenuse is AB, which is 2A. This is corresponding to angle B, which is 60 degrees. Now sine 60 is perpendicular by hypotenuse, which is root 3A by 2A, which is equal to root 3 by 2. Cos 60 degrees is base by hypotenuse, which is A by 2A, so this becomes 1 by 2. Tan 60 is perpendicular by base, which is root 3A by A, which is root 3. Cot 60 is base by perpendicular or reciprocal of tan, so we get 1 by root 3. Cosecant 60 is reciprocal of sine 60, which is 2 by root 3. And secant 60 is reciprocal of cos 60, which is equal to 2. For the trigonometric ratio of 30 degrees, the equilateral triangle ABC, in this we take this right angle triangle ABD. Since AD is the perpendicular, so it is bisecting this angle A. So now angle BAD becomes 30 degrees. So the base for this will be AD, which is equal to root 3A. The perpendicular is BD, which is A, and the hypotenuse is AB, which is equal to 2A. This is corresponding to this 30 degrees. So sine 30 is equal to A by 2A, which is 1 by 2. Cos 30 degrees is root 3A by 2A, which is root 3 by 2. Tan 30 is A by root 3A, which is 1 by root 3. Cosecant 30 is 1 by sine 30, which is 2. Secant 30 is 1 by cos 30, which is 2 by root 3. Cot 30 is 1 by tan 30, which is equal to root 3. The trigonometric ratios of complementary angles. Two angles are said to be complementary to each other if the sum is 90 degrees. So, theta and 90 minus theta are complementary angles. Let us consider this triangle ABC, which is right angled at B. So, we know that in this triangle, angle A plus angle B plus angle C is 180 degrees. So, since B is 90 degrees, so angle A plus angle C becomes 90 degrees. So, what is angle C? It is 90 minus A. So, here angle A and angle C are complementary angles. So, trigonometric ratios of angle C, sin C is equal to sine of 90 minus A, which is AB by AC. Cos C is cos of 90 minus A, which is equal to BC by AC. Tan C is equal to tan of 90 minus A, which is equal to AB by BC. Cosecant C is cosecant of 90 minus A, which is AC by AB. Secant C is secant of 90 minus A, which is AC by BC. Cot C is cot of 90 minus A, which is BC by AB. Similarly, trigonometric ratios of angle A will be cos A is AB by AC, Sin A is BC by AC, cot A is AB by BC, secant A is AC by AB, cosecant A is AC by BC, and tan A is equal to BC by AB. Now when we compare these two ratios of angle C and angle A, we find that sine of 90 minus A is equal to cos A because both are equal to AB by AC. Similarly, cos of 90 minus A is equal to sin A. Tan of 90 minus A is equal to cot A. Cosecant of 90 minus A is equal to secant A. Secant of 90 minus A is equal to cosecant A. And cot of 90 minus A is equal to tan A. Now let us know something about this trigonometric identities. An equation is called an identity when it is true for all the values of variables involved in the equation. An equation involving trigonometric ratios of an angle theta is said to be a trigonometric identity if it is satisfied for all the values of theta for which the given trigonometric ratios are defined. So first let us take the Pythagorean identities. The first identity is sin square theta plus cos square theta equal to 1. When we consider this right angle triangle ABC, right angled at B, sin theta is equal to BC by AC and cos theta is AB by AC. Taking the left hand side, when we substitute, we get BC square by AC square is equal to AB square by AC square. Taking LCM, we get BC square plus AB square is equal to by AC square. Now BC square plus AB square is equal to AC square according to the Pythagorean theorem. So this becomes equal to 1. So sin square theta plus cos square theta is equal to 1. The corollary is sin square theta is equal to 1 minus cos square theta and cos square theta is equal to 1 minus sin square theta. The second identity is secant square theta minus tan square theta equal to 1. In the right angle triangle ABC, right angled at B, 1 plus tan square theta. So tan square theta is BC square by AB square. When we take LCM, we get AB square plus BC square by AB square. Clearly, AB square plus BC square is equal to AC square according to the Pythagoras theorem. So this becomes AC square by BC square, which is nothing but secant square theta. So secant square theta minus tan square theta is equal to 1. Now though this is an identity, yet this is not true for theta is equal to 90 degrees because previously in the chart you can see that at theta equal to 90 degrees, tan theta and secant theta are not defined. The corollary of this identity is tan square theta is equal to secant square theta minus 1. Similarly, secant square theta minus tan square theta equal to 1. This is of the form of a square minus b square. So we can write it as secant theta minus tan theta into secant theta plus tan theta is equal to 1. Taking it to the right hand side, we get secant theta minus tan theta is equal to 1 by secant theta plus tan theta where theta is not equal to 90 degrees. The third identity is cosecant square theta minus cot square theta equal to 1. In the right angle triangle ABC, right angled at B, 1 plus cot square theta is equal to 1 plus AB square by BC square. So BC, when we take the LCM, we get BC square plus AB square by BC square. Now BC square plus AB square is AC square according to Pythagoras theorem. So we get AC square by BC square, which is equal to cosecant square theta. So 1 plus cot square theta is equal to cosecant square theta where theta is not equal to 0 degrees. So cosecant square theta minus cot square theta equal to 1. Now this identity is not true when theta is equal to 0 degrees because cot theta and cosecant theta are not defined at theta equal to 0 degrees. The corollary is cosecant square theta is equal to 1 plus cot square theta. Cot square theta is equal to cosecant square theta minus 1. Cosecant square theta minus cot square theta equal to 1. So this can be written as cosecant theta minus cot theta into cosecant theta plus cot theta equal to 1. Taking this to the right hand side, we get cosecant theta minus cot theta equal to 1 by cosecant theta plus cot theta where theta is not equal to 0. Now this is a chart where we can express each trigonometric ratio in terms of any other trigonometric ratios using the fundamental identities. Now here theta is an acute angle. We can go through this chart. It will be helpful for solving your problems. Thanks for watching. If this video helped you understand the basics of trigonometry, don't forget to like the video and subscribe to Maths with Mamta for more easy and clear explanations. In the next video, we'll start solving important questions. See you soon.